All right, so solving systems of equations. We're going to be doing an introduction followed by an activity tomorrow in class as an introduction to solving systems of equations. So first off, starting out chapter 6 here, all about systems of equations. First off, what is a system of equations? And the official definition, system of linear equations, is a set of two or more linear equations containing two or more variables. So in general, what we're going to be seeing is equations like we've been seeing the past chapter. Linear equations, remember, are equations that can be written as AX, so your official definition was AX plus BY equals C. So a system of linear equations would be, maybe I take y equals negative 2x plus 5 and 3x minus 2y equals 7. I take two equations and I'm considering them at the same time. So this little bracket, curly bracket, tells me that this is a set, that those belong together. And notice both are linear equations, even if they're written in different formats, and they contain two variables in this case, although we could expand it into 3, 4, 5. Start throwing in x, y, and z, or w, x, y, and z. But that will come later, like Algebra 2 later, or bonus question later. But a set of latent linear equations is what we consider to be a system. So first off, and this is all we're going to be covering in this video, is if we're going to talk about solving systems of equations, we need to know what the heck we mean when we're talking about a solution. So a solution to a system of equations, or solutions, are ordered pair that satisfies each equation in a system. So for instance, if I were to draw, and my lines aren't that straight, but that's okay. If I were to draw, let's say we had the equation y equals 2x plus 5. Start at my y-intercept of 5, go up 2 over 1, down to left 1. If I looked at my line here, a solution to just a linear equation. Do we know what a solution means? A solution is any point that's on the line. So for instance, if I look at this point, 1, 7. 1, 7 is a solution to this individual linear equation. When does it become a solution to a system? Well, if you notice, a solution is a point, any point that's on the line. So we might calculate this one, 1/2, 6, negative 1/2, 4, it looks like. Solutions to an equation are a number that's, or a point that is on the line, that's shaded in on the line. If it's a solution to a system of equations, that means it's a solution to both equations, to both lines. So for instance, let's say, and I'm just drawing in another random line, it's not, I didn't purposefully pick this or make it come up with this from an actual equation. But if we take a second line, and if you notice where I graph it, all the points, I'm assuming I can draw a straight line, all of these points are solutions to the equation that I just drew. The solution to the system, so I'm going to cross this out so we don't get confused, would be the points that are on both lines. So in this case, there's only one. So the solution to the system would be negative 2, 1. So we're going to talk later about how we actually find these points. One of the ways would be graphing. But for right now, we want to be able to tell, first off, what is a system of equations, and then number 2, how do I know if it is a solution? So if I go back to my original example here and I said 1, 7 was a solution to this line, what that's really telling me is if I put 1 in for x and 7 in for y, this gives me a true equation. So if I plug in 1 for x and 7 for y, notice I end up with 7 equals to 7. That is true. If a solution is a solution to the system, not just to one equation, then it's going to satisfy each equation. So in this case, going to satisfy both equations. So if I look at my I do here, and I'm saying, is 4, 1 a solution to the system? I have to check not only the first equation, but I also have to check the second equation. And if you notice, both of those are written in standard form. So the only way this is a solution, and I plug in 4 for x and 1 for y, is if when I plug these numbers in, and notice I'm doing it with parentheses, is if it's a solution to both equations. So this should be 4 plus 2 equals 6. 6 equals 6. So yes, it's a solution to the first equation, so I'm just going to check that off to make sure I keep track. And if I plug it into the second equation, 4 minus parentheses 1 equals 3. Is 4 minus 1 3? You betcha. So that means yes, it is a solution to the second equation. So is it a solution to the system? Yes. If it were a solution to only one of the equations or to neither, that would mean it's not a solution to the system. So here's your you do. Is negative 1, 2 a solution of the system? So pause and try this. So if I plug in 2 times negative 1, there's my x, there's my y. Plus 5 times 2 equals 8. Does negative 2 plus 10 equal 8? Yes, it does. So this is a solution to the first equation. Do not assume if this is a solution to one equation that it's a solution to both. Plug into the second equation. 3 times negative 1 minus 2 times 2 equals 5. Negative 3 minus 4 equals 5. Negative 7 equals 5. If we get a nonsensical statement, definitely not true, then that means it's not a solution to this equation, so it's not a solution to the system. What that means is this point is on the first line, but it's not on the second line. So we want to be able to verify solution or not a solution. In the second one here, your you do was not a solution. The last thing that we want to think about, just to kind of give you a little bit of future thought here, is when we're talking about solving systems of equations, we've got to realize how many solutions am I actually looking for? What are the possible solutions? So when we're looking at systems of equations, we're really looking for their intersection point. Where do those two lines meet? So if I have two straight lines, I want to think, how could these two lines actually intersect? So our most traditional setup, and the one you'll see the most often, is two lines just crossing. How many times could two lines intersect? Well, they could intersect once. So we could have one solution. But what are other possibilities? Are there any other ways that lines can intersect? Well, we've seen both of these. What if I had a line and I had, bear with me the best I can do here, what if I had parallel lines? How many solutions would I have? Well, if they never intersect, that would mean there's no solutions. There's a third case, and what would the third case be? Well, let's think if I had a line. How else could I draw a line that intersects with this one? Well, what if I drew, and again, bear with me to do the best I can here. What if I drew the same equation? If you remember, we called these coinciding or coinciding lines, or the same line, the exact same equation. How many solutions would there be here? Well, there would be an infinite number of solutions. That doesn't mean that any number would be the solution. It means that there's an infinite number of possibilities. So any points that these two lines share would be considered solutions. So if you notice, if I keep putting dots on here, I could keep going forever and ever and ever. So thinking about solutions, what does it mean to be a system of equations? What does it mean to be the solution for a system? Over the next couple of days, we're going to talk about the ways that you can actually go about solving these systems. But keep in mind, the different situations that you may come across.